and welcome to another one of these ADD videos. Today we're going to be looking at the concept of domain. And domain basically is the collection of all the defined x values, or your independent variable. And there are three basic scenarios that you can look out for that'll make your life much easier to deal with this concept of domain. I think I zoomed out a little too much. There we are. So the first scenario that we're going to look at is anytime we have a denominator, we know that that denominator, or you should know that that denominator can never equal 0. If you have a number over 0, it basically becomes something we refer to as undefined. And what you want to do is you basically want to take whatever you have down here in this denominator and you want to set it not equal to 0 and solve. And your domain is going to be all the real numbers out there except for the solutions to this denominator there. So in essence, where it equals 0 is where your domain cannot be. You cannot plug in a number that makes that bottom equal to 0. Okay. The next restriction you got to keep an eye out for are these square roots, the radicals. Okay. Anytime you have a radical like that and the power here is even, or there's nothing there, in this case, square root is nothing there with a 2, right? Then what we have to know is that the domain has to be positive. You can never take an even root of a negative number. You can do an odd root, like if there's a cube root, there'd be no problems. But if it's a square root, for instance, then we have problems. So what you got to do is you set up an inequality wherever whatever's under the denominator is greater than or equal to 0, then you solve the inequality. Okay. Now keep your eyes open, because oftentimes what they'll do is they'll try to trick you, because if the power of the highest x, or the degree, is greater than 1, okay, you cannot just outright solve it. What you have to do is you have to do a sign analysis, okay, and the sign analysis, you basically set it equal to 0, and you get these cut points. Oops, I should have not done the plus sign, sorry. What you do is you get these cut points here, wherever those equal to 0, and you then have to use these test points to see if you get a positive or a negative answer when you plug it into your original equation. And because we're looking for greater than or equal to 0, your domain would be the regions that have these plus signs on them. Okay. Now, you could also have a rational expression. What is a rational expression, in case you forgot? That's just a fraction of x's or whatever variable you're dealing with on top and bottom. So if you have a rational expression under this square root, under the radical, then you got to set the whole thing greater than or equal to 0, and then you do sign analysis again. Okay. Now, the only difference between this rule and the next rule is that the square root is on the bottom. Now, if your square root is on the denominator, then we've added the restriction of not equaling 0. If you remember, the denominator can never equal 0. So the way we do that mathematically is by combining rule 1 and 2, we look at this rule that says just set whatever's in the denominator under the square root greater than 0. Okay. If you can do that, then solve the inequality if it's the power of x of 1. But if it's greater than 1, do your sign analysis, and there will be a video dedicated to sign analysis by itself. Then you're good to go. Okay. So 3 things to keep an eye out for: denominators, radicals, and radicals in the denominator. Okay. That's the basic concept of domain. Make sure you check out the example videos. I'll do some basic examples and then some more advanced ones as well. And practice, practice, practice. That's the most important part. Domain's fairly straightforward, so if you do enough of these, you should be able to get them pretty quickly. All right? I hope I've cleared up any confusion you might have. Thank you and have a nice day.